Imagine logging into Slack, tagging an AI agent, and just watching it autonomously comb through your company's legacy Java code base.
Right. And it diagnoses a memory leak, writes the fix, tests it.
Yeah, and submits a pull request for deployment, all while you're still waiting for your morning coffee to brew. I mean, we aren't talking about some science fiction concept here or, a tech demo slated for next year. This is the reality of what was pushed to production just this week.
Which is, I mean, it completely upends how we need to think about the software we use every day.
Yeah.
Because for a long time, the tech industry has just treated AI as, well, a really articulate, very fast chatbot. Like you type a prompt, it gives you text. It was essentially an assistant sitting on the sidelines.
Exactly. And if you're listening to this right now, your job is about to change because the AI is getting off the sidelines. So, welcome to the deep dive. Our mission today is to unpack a massive stack of technical news straight from the desk of Andrew Kagan.
Yeah, and his weekly newsletter covers 8 distinct focus areas across the Microsoft and enterprise tech ecosystem.
Right, from Azure infrastructure down to DevOps, data security, everything. And looking across all of these updates, there is a singular massive shift happening. We are moving from, AI as a helpful chatbot into the era of autonomous agents doing actual work.
The industry is calling it the agentic shift. And it fundamentally changes the requirements for how we build, secure, and manage technology.
Yeah.
Because, you're no longer just managing users. You're managing digital entities that can literally take action on their own.
And by the end of this deep dive, you're going to understand exactly how this shift operates at every single level of the tech stack. So let's start where the software actually gets built, right? DevOps. The sources highlight a concept from O'Reilly called agent harness engineering. And I kind of want to pause on that term because a harness implies something pulling and, something holding it back.
That is a highly accurate way to look at it.
Yeah.
The AI model itself, like the neural network, is just the engine.
Yeah.
It has raw power, but no direction. So a coding agent is the model plus the harness you build around it.
Okay, so it's not just like putting bumpers on a bowling lane so it hits the pins. It's more like, I don't know, a leash on a very strong sled dog. Like the model wants to pull forward and write 1,000 lines of code, but the harness is the automated testing pipelines and the syntax checkers.
Yeah, the contextual constraints that yank the leash back when the AI tries to run the whole sled into oncoming traffic.
Exactly. And that harness tightens every single time the agent makes a mistake.
Wait, how does this actually work in practice, though? I mean, is this just theory?
Not at all. To see this in action, look at Pulumi's new Neo agent. So Pulumi is a platform for managing cloud infrastructure as code, and they're betting that the next decade of infrastructure management will be entirely AI-driven. So Neo is this autonomous agent that handles ephemeral cloud accounts. It runs scheduled drift detection to see if your servers actually match your configuration and conducts compliance audits. But wait, I have to challenge this. Is Neo actually fixing the infrastructure, or is it just, acting like a glorified spell checker that highlights a problem and then waits for a human engineer to do the heavy lifting?
No, it investigates the failure, it proposes the fixes, and can literally submit those changes as GitHub pull requests. Yeah. And it integrates directly into Slack.
Oh, wow.
Yeah, you can tag it in a channel, tell it the staging environment is throwing errors, and it will just go read the logs and start fixing it.
That level of machine-to-machine communication is wild.
They go deeper than Slack. The sources highlight a project called Vercel Zero, and this is where the compilers themselves, the foundational tools that translate human-written code into machine language, are being rewritten.
Rewritten how?
Well, the error messages they generate are no longer meant for human eyes. They're structuring those error logs specifically so AI agents can read them, understand the failure, and instantly write a patch.
I mean, that makes perfect sense for new software, right? But what about a company drowning in 20-year-old technical debt? Because the sources mention a Java app modernization project involving this legacy app called Java Social. It had an ancient .NET backend and this outdated Java frontend. How does a leash or a harness help an AI untangle that mess without breaking the whole system?
By enforcing a really methodical, stepped approach. Because, a human wouldn't just rip out the foundation of a house all at once, and the AI agent's harness prevents it from doing so either. So in the Java Social example, the agent analyzed the legacy code and realized it couldn't jump straight to the newest software version.
Okay, so what did it do?
It planned intermediate milestones. It upgraded the Spring Boot framework from version 1.5 to 3.3. Then it paused, tested the code, read the compatibility logs, fixed the breaks, and only then moved the system up to version 3.4.
So it's literally dismantling the engine, swapping out the pistons, and putting it back together while the car is driving down the highway.
Essentially, yeah.
But I gotta say, if I'm a bank or a defense contractor, I am absolutely not letting a public cloud AI model look at my proprietary source code or my server logs. I mean, the regulatory fines alone would bankrupt the company.
Which is exactly the primary barrier to this agentic shift for highly regulated industries. I mean, they want the operational speed of these AI agents, but they require absolute data sovereignty. And this explains the massive industry news from Dell and Palantir this week. They are bringing this entire capability on premises.
Meaning they are just ripping the AI out of the public cloud and locking it in a physical basement.
Basically,
Ugh.
they are introducing a full AI operating system using the Dell AI Factory with NVIDIA chips. It brings Palantir's Foundry and Ontology platforms entirely on-prem.
Right.
So a defense contractor gets the full power of autonomous agents, but the data never actually leaves their physical building, which ensures zero trust security.
Okay, so we have these highly capable agents managing back-end DevOps code and running in secure server rooms. Let's pivot to the everyday user, the person sitting in HR or finance. How does this actually surface for them? Because the Microsoft Power Platform updates introduce something called computer using agents in Copilot Studio. And please tell me that doesn't mean the AI is physically taking over my mouse cursor.
Well, it means they can navigate user interfaces. These agents are now generally available across commercial regions. And instead of just calling some hidden API in the background, a computer-using agent can interpret a screen, click buttons, and fill out fields inside web applications on your behalf.
That is slightly terrifying, but also incredibly powerful. And it changes how the AI responds to us, too, right? Because the sources detailed a demo from a fictitious company called Tree Research. Someone asked the AI to find a consultant with specific JavaScript skills to assign to a new project. Historically, the AI would just print out a text list of 3 names, and you'd have to go manually enter them into your project management software.
Right, but the Tree Research demo shows the leap forward. Instead of text, the agent used an MCPA Model Context Protocol server.
Okay, let's translate that for a second. What does that protocol actually do?
It allows the AI model to pull in real-time context from external tools and render actual software code right in the chat window. So in this case, the agent generated an interactive React-based user interface widget on the fly.
Wait, really? Like a full interface?
Yeah, it looked like a mini dashboard with sliders, filters, and a functional assign button right there in the conversation.
So it is building bespoke, single-use software applications based on whatever you just asked it to do 5 seconds ago. And Google is backing this concept too, right? With a new open source standard called A2UI, or Agent to User Interface. It seems like they are all trying to figure out how to make AI visual. We see this in the Microsoft 365 Copilot May 2026 updates as well. The new GPT 5.5 models are being integrated with options to, think deeper before answering. But if I give a computer-using agent access to Excel, I have to be honest. One bad formula change can completely tank a quarterly financial model. How do we trust it?
Trust requires transparency, which is exactly why Microsoft introduced the new plan mode in Excel. Before the Copilot agent executes any changes or writes a single formula, it stops. It generates a step-by-step, plain English plan of exactly what it intends to do to your spreadsheet.
Ah, the leash again. You review the plan, and it only executes if you approve. Microsoft seems to be aggressively cleaning house to make room for these agents too. The sources note a few M365 admin updates, like Teams is officially retiring the old Together mode in favor of a clean 49-person gallery, and Exchange is finally rolling out a write-back feature for cloud-managed remote mailboxes, which lets IT admins permanently turn off their last remaining on-premises Exchange servers. They're just stripping out the old legacy clutter.
Because the new infrastructure demands efficiency. But here's the thing. An agent, no matter how efficient its interface is completely useless if it doesn't have access to your organization's data. I mean, a genius assistant with no access to the filing cabinet can't actually do anything.
Which brings us to the data, analytics, and AI updates. Microsoft Fabric is the solution to that filing cabinet problem, isn't it? They are pushing a feature called Link to Fabric, which connects isolated business data like customer records in Dynamics 365 directly into one lake. You aren't constantly exporting and importing CSV files anymore.
Right. You are bringing the AI directly to a single, unified source of truth. And developers are finally getting the tools to manage this properly. The Power BI May updates include a massive change to the Copilot tooling format.
Yeah, I noticed this in the sources. The old format was called LSDL. And from what I understand, LSDL was a completely undocumented black box. If you were a developer trying to prep your data for AI, you were flying blind. Like,
Ab-
if you made a mistake, you couldn't easily roll it back or see what changed.
It was incredibly frustrating for engineering teams. But the new format replaces that black box with something Git-friendly.
Meaning it acts like standard software code?
Yes. A developer can use version control. They can see line-by-line differences, do code reviews, and track changes to the AI metadata over time. They're finally treating AI configuration like real engineering.
Which is so critical for stability. But it is also important to note that the beta landscape is fracturing a bit. Not every enterprise wants to rely solely on OpenAI models. Microsoft Foundry is bringing in Fireworks AI to host frontier open models directly on Azure, specifically DeepSeek V4 Pro and Kimi K2.6.
Yeah.
And the sources mentioned they are adding PTUs to the US data zone for this. Let's break that down, because a PTU is a provision throughput unit. Why does a company actually care about a PTU?
Because if you are running a massive enterprise-grade AI agent, you just cannot afford to have your system slow down just because a million other people on the internet decided to use ChatGPT at the same time.
Right.
A PTU allows a company to reserve dedicated processing power. You get guaranteed predictable performance, and by putting these PTUs in the U.S. data zone, Microsoft is giving regulated companies the ability to use open source models while legally guaranteeing their data never leaves the country.
Okay, so we have autonomous agents, we have rich UI dashboards generating on the fly, and we have unified data lakes fueling their brains. But at the end of the day, all of this digital magic has to run on physical metal in a data center somewhere. So let's look at the bedrock. Azure infrastructure. The May updates detail the new Azure Boost generation, the ESV7, DSV7, and DLSV7 virtual machines. And this isn't just a software patch, is it?
Not at all. It is a total hardware architectural shift. Azure Boost was in development for over 5 years. It relies on a custom ASIC and an FPGA hybrid accelerator alongside a dedicated system on chip.
Okay, let's translate that hardware jargon for a second. So an ASIC is an application-specific integrated circuit. Instead of a general processor like the one in your laptop that does a little bit of everything, an ASIC is physically forged in silicon to do one specific job at blinding speed.
Exactly.
And an FPGA is hardware that you can actually reprogram on the fly. Why does Azure need both?
Well, because virtualization, which is the process of splitting one giant physical server into dozens of smaller virtual machines for customers, takes a massive amount of processing power. Traditionally, the main CPU handles the network traffic, the storage routing, and the security checks.
Which steals processing power away from the customer's actual application.
Exactly. So Azure Boost takes all of those virtualization tasks and offloads them onto these custom ASIC and FPGA chips. The main CPU is completely freed up. Pair that with their new Man-in-A network adapter, delivering 400 gigabits per second, and your AI workloads get the full, unthrottled power of the server at wire speed.
Unbelievable. But honestly, the hardware isn't even the most shocking part of the Azure stack this week. I mean, I had to read the source notes twice to believe it. Microsoft just released a full general-purpose server Linux distribution.
Yeah, Azure Linux 4.0.
Wait, Microsoft? I mean, 20 years ago, leadership famously referred to Linux as a cancer. Now they are shipping a supported Fedora-based Linux operating system. Why the massive pivot?
It is a pure security play dictated by the AI era. More than 2/3 of the customer cores running on Azure today are running Linux.
Oh, wow, really?
Yeah, and OpenAI's entire infrastructure sits on a Linux foundation. If Microsoft is going to host the world's most critical AI agents, they cannot rely on a third-party operating system. They need absolute ironclad control over the entire supply chain.
Right, they need to curate every package, strip out any unnecessary code that could be a vulnerability, and just ensure the base layer is secure.
Exactly. And you're even offering something called Azure Container Linux, which is an immutable version, and they're bringing it to Windows 11 via WSL.
Okay, immutable meaning the operating system cannot be altered once it is running, right?
Yes. You can't install new system packages or tweak the core files. You just run your AI containers on top of it. So if an attacker breaches the container, they can't change the underlying operating system because it is mathematically locked down.
And if you need to run those containers quickly, they announced Azure Container Apps Express in preview, which offers sub-second cold starts and scale to 0 per second billing.
Which is absolutely perfect for spinning up AI agents instantly.
Right. You can spin up a specialized AI agent in milliseconds, run a task, scale it back to 0, and only pay for the exact seconds it was alive. Which forces us to look at the final and undoubtedly most critical piece of this entire puzzle: security and compliance.
Oh yeah, security is the choke point.
Fair.
Every chief information security officer is looking at this agentic shift and seeing a nightmare scenario.
I mean, it is terrifying. If I have an AI agent with access to all my unified data running on insanely fast infrastructure and it literally has the power to click buttons in my applications, how on earth do I stop it from getting confused and accidentally emailing my company's payroll spreadsheet to an external contractor?
Right. Well, the sources outline a three-pillars approach to end-to-end AI security to prevent exactly that.
Hmm.
The pillars are Purview, DSPM, Agent 365, and the AI Security Dashboard.
Okay, let's unpack DSPM data security posture management. A dashboard just shows me what's happening, and Agent 365 manages the identity of the agent. But how does Purview actually act as the kill switch?
The secret weapon lies in Purview sensitivity labels, specifically the extract usage right. Because in the past, companies tried to control AI by writing system prompts, essentially just asking the AI very nicely not to share confidential data. But LLMs can be tricked.
Right, prompt injection attacks can bypass those rules easily.
Exactly. So Microsoft moved the defense to the physical data layer. You apply a Purview label to that payroll spreadsheet and explicitly deny the extract permission. When an AI agent attempts to read that file to answer a user's prompt, Purview intervenes. It drops the connection before the data ever reaches the AI model.
Wow, so the AI cannot leak what it physically cannot see. It doesn't matter if the agent is tricked because the infrastructure itself slams the door shut.
Exactly. And we are seeing security agents actively hunting threats too. The updates mention Sentinel triage agents running in VS Code.
Right, they are hunting suspicious deployments by looking at specific telemetry like checking if the claim identity type equals app to catch malicious automated scripts trying to sneak in.
Because the threats are evolving rapidly. The sources mentioned a recent attack called the Yellow Key BitLocker bypass, which exploited the Windows recovery environment to steal encrypted keys. Traditional software defenses are struggling to keep up, which is why security is moving down into the physical hardware.
The Western Digital announcement is a perfect example of this. They are adding NIST-approved post-quantum cryptography to their new UltraStar hard drives.
Let's explain why that matters today. Because quantum computers powerful enough to break modern encryption do not currently exist.
But the attackers aren't waiting. They're executing what's called a harvest now, decrypt later attack.
Yeah.
State-sponsored hackers are stealing massive amounts of encrypted data today. Financial records, military secrets, and just storing it in massive data centers. They know they can't read it right now, but they are patiently waiting for 5 or 10 years until a quantum computer is invented to finally break the math.
And Western Digital is embedding defenses into hard drives today to secure data against a machine from the future. It is the only way to protect long-term secrets.
Which brings up a critical question for you listening right now. How are you supposed to keep up with all of this? I mean, the skills required to be an IT professional today look nothing like they did even 2 years ago.
The certification landscape is completely restructuring around this. Microsoft just announced a new certification in beta, Exam SE 500, the Microsoft Certified Cloud and AI Security Engineer Associate.
Right, and it forces professionals to prove their skills across identity management, data protection, AI models, and cloud threat defense simultaneously. It's no longer just about, setting up a firewall. It is about engineering the harness around the agent.
And if you are just trying to get your team to use these tools effectively, there is the redesigned Copilot Adoption Hub, which is packed with finding specific prompts and role-specific use cases. It is a top-to-bottom rewrite of the enterprise playbook.
Absolutely. So to quickly recap the incredible velocity of this agentic shift we've explored today, we started at the bedrock with custom Silicon and secure Linux operating systems, moved up to data lakes, bridging legacy silos, watched as AI agents started writing pull requests and clicking our desktop apps, and finally saw how data layer security is physically cutting off access to keep these autonomous workers from leaking our secrets.
The infrastructure, the interface, and the security are all aligning to support autonomous action.
They really are. But I want to leave you with a final mind-bending question to ponder as we wrap up this deep dive. We've spent this entire time talking about how you build the harness, how you manage the data, and how you secure your AI agents within your own company's walls. But think about the logical next step.
What happens when they interact?
Exactly. What happens in a year or two when your company's AI agent needs to negotiate a vendor contract or share supply chain data with a competitor's AI agent? If both agents are authorized to take action, read files, and click buttons, who sets the rules of engagement when AI talks to AI in the wild? It is a fascinating new frontier. Thank you so much for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you next time.